This can be a hands-on workshop. It might go a little fast for that, but you will get to the point of actually seeing how the software works. But before that, for those of you that are interested, you can obviously come and join our community. We have some community members in the room that worked on our hackathon, one of many hackathons earlier today. This will take you to an invite, so you can join our Discord, and you get direct access to both our dev relations and then actually the engineers that are working on the system itself. So folks like Thomas Kerber, for example, who wrote the original paper on Kachina, which is the programming model we use, occasionally answers your questions. So I would encourage you to come this direction if you're interested. I'll leave it up there for a few more minutes. But we very much want and need to build the community. We're there to empower you guys to be able to do your work, and we're there to make the nice, smooth experience. So feel free to come on in and let us know your thoughts. So I'm going to make a little bit of a comparison here from traditional web applications and then work through blockchain and into what Midnight provides. So a traditional web application looks something similar to this, where you have the user over on the left side, and then you have the company providing that interface on the right side, right? A website application that you call out to. You interact with that through a bunch of data packets, right? You load up your web browser, you can see who it's connecting to, what type of information it's passing, and what you're doing is you're communicating basically any data that you need to interact with that application over the internet. So if I'm logging in with my username and password, going over the internet. If I'm using my credit card, going over the internet. Obviously, there are controls that the company's put in place so that, hopefully they don't show up in the news for some type of breach. But the data that they collect is in their possession, and they can use it for their own purposes, right? Whether that be to advertise to you or some other state. And so it's basically a very valuable piece of information that you have no rights to. Even if it is your data, even if it is the content that you produced, it's still theirs. And what Midnight does is Midnight enables that to go away. So today, sending this sensitive and private data is just a general occurrence. We do it all the time. Basically, every app that you want to use does this, and we need to find a better way because we don't want to empower all of these organizations with our data. We want to empower the user to be able to retain their data. All right, so let's move into blockchain, right? So some people may think, oh, blockchain's the solution to this. Blockchain puts me in control of my own information. Oh, it puts you in control of your keys, right? So you can sign things and submit. It takes the company out of the mix a little bit, right? The company can provide a DApp, but in some cases you're interacting with the chain, right? So the information is going to the chain. It's not directly moving all the way over to the company. However, for those of you that are steeped in the technology, which I think many of you are, you may realize that these chains are transparent. So you can see the interactions that are going on. You can see where the funds are. You could go check my balance if you knew what my address is. So rather than having the company just be able to capture this information and use it for their own good, now you have a chain that's capturing it, and now basically anybody can use it for their own good. Right? They can start to advertise to you based off of what dApps you're using and how often you use it, and start to target you. So even though it's giving the power back to the user, it's in a way revealing even more information than you do in other contexts, which may or may not be beneficial, right? If you go into a McDonald's, you don't really know what the balance of the cash register is, nor should you. But in this context, you would. You could absolutely see how many funds are held in there. So both the application data and the metadata is public in this sense, right? And so there's definite issues that show up there. However, you do gain a lot of advantages just moving in this direction. Okay, so what does Midnight do? Why is Midnight different? So again, we have the user, still resident over there on the left-hand side. In this case, the user actually has private data. So beyond just a signing key, it has additional data that is resident with that user and can stay on their laptop in their environment and never actually traverse the internet to anywhere else. That private data can include things like contracts, it could include things like credentials, it could include proprietary processes, it could include medical data, it could include anything that you want to interact with, but it would be illogical to put it on chain, right? I'm not going to put my medical history on chain. I might put evidence of it, but I'm not going to put the whole thing. And so what actually traverses from the user to the chain is proofs. Proofs of the information that you have, not the data itself. There can be some transparent interactions, but a lot of them are just simply proofs. Are you old enough to do this? Are you qualified to do this? Do you have the appropriate assets to perform this function? Yes, no. That's what the proof is. Those proofs move on to the chain, and since they're zero-knowledge proofs, you can go download them, but they're basically cryptographic garbage. There's nothing you can do with them unless you actually have the witness to understand it, which is what's in that private data. Midnight provides both a shielded and unshielded version of this, so you can have information that is public that you can coordinate across many users so that you can actually interact, play games, have a marketplace. But then it also has the shielded portion where if you want to do an interaction where you perform a function but you don't want everybody to see it, like for the example, the McDonald's cash register, you can shield that. So you can tell somebody paid for their meal, but you can't necessarily tell what the deposit was, how much is there and how much is resident in that location. And so what this allows us to do is it allows us to take a step beyond what blockchains allow you to do now, and it moves us more towards applications that an enterprise would be interested in, right? Any application that an enterprise has almost always has private information, right? There's some element that they have an asymmetric piece of information that is allowing them to do this transaction, and they certainly don't want to reveal that. If you have this ability to submit a proof where you retain ownership of that private information, now you can take that action and you're not revealing to everybody else on the planet what's going on. And then what actually moves over to the company that's providing the smart contract capability for you is simply updates of states of the smart contract. So if you're playing a game, maybe it's an update where it says it's the opponent's turn, not your turn, right? That could be public. But it's not necessarily the entire package. You don't see the whole thing. Okay, so I'm gonna keep walking into this a little bit deeper and deeper as we go today. The workshop has a few objectives. Objective number one is not for you to listen to me talk for the next 45 minutes, hour, however long this takes. So feel free to interrupt, feel free to raise your hand, right? Any question you have, I'd be happy to answer if I can, or figure out what the answer is after the fact. We're gonna walk you through 3 steps. The first step is starting to understand what Midnight is specifically, and what Compact is, which is the smart contract language that we provide. After that, we're gonna actually start building and using Midnight. So you're gonna see some of the demos that maybe you've seen online for how you can set up your system to transact, so get a wallet, get funds, send funds, how you can set up a development environment so you can actually build these contracts, compile them, deploy them, and then actually using a smart contract. We'll show you that as well. All of this is publicly available. Even if you see me talk about it today here, you can come back after the fact, absolutely going through the Discord and asking questions, and we can get you over the line. And then at the end, we're going to provide more ways of getting assistance and then ways of contributing, right? So much like the rest of Web3, we are going to be a public chain. We're going to have public code. We want contributors. We want people to use the tools. We want people to test them out. We want people to tell us what they don't like, right? I'm not looking for people without opinions. I want everybody to have an opinion, hopefully positive. And if you find things that have rough edges, raise your hand, let us know. We'll smooth them out as quickly as we can. So just kind of driving down the agenda a little bit, right? So the 3 objectives, just like a moment ago. So the overview of Midnight, you're actually gonna, I think by the end of this, understand how we perform this function where we have private data and that we can interact with smart contracts. In addition to that, you're gonna get introduced to Compact. So Compact's a smart programming language that we provide. If you've seen Solidity or TypeScript, this is gonna be a short step for you to be able to interact with what Compact has. We're gonna show you a few elements of it that allows this zero knowledge function to execute more quickly. And so as you start to understand these components, you'll be able to build contracts that both execute faster and cost less gas, right, or less dust. When we move on from there, we're going to actually start building and using. The use cases that I'll show, every single one of them is in our docs. So you can go through them step by step. They do work on Macs and Windows and Linux to some extent. So we'll talk about that, and we'll look for input. You'll be able to set up a development environment. So if you're a Visual Studio Code user, you'll get to start to see what our initial interactions are. We can talk about our roadmap, where we're going with that to make that development environment more advanced, so it has the creature comforts that you're used to, you're going to get from other languages. We're going to walk through building a DApp. We're going to walk through two of them, one of them a little bit, and one more complicated one in full. And if you're quick with the camera or with your typing, you'll be able to interact with it as well. And then once we're done with that, on to how do you get assistance and how can you contribute, right, as I mentioned. So there is a roadmap that we're going to talk about, how we're getting to mainnet. Currently we're in DevNet. Shortly we're going to be in testnet. And the goal for mainnet is early next year. DevNet is open to all. You can all go access it today. You can do the same exact things I'll be showing you. You can build your own. You can contribute. You can join our community calls, which I think we had one 2 or 3 hours ago, every Friday, right, to come and show us what you have, ask questions, find other people in the community to help you push your own project forward. And then at the end, we'll start talking about some hackathons. So we have one that's concluding here, but we're going to have many more. So there's going to be lots of opportunities for this, both in person and virtual. And so attract your attention to that, and hopefully we'll see you at those in the future. All right, before I move on, any questions, comments? No? Everybody still awake? Yeah? Okay. All right, so let's talk about Midnight a little bit more. So the mission of Midnight, I'm on the wrong side here, is that we want to unblock the widespread adoption of a decentralized web, right? So we have applications that are live in Web3 today. They're limited in some ways to certain industries and certain use cases, and the adoption just hasn't penetrated into a broader audience. We think that we can move in that exact direction using a tool like what Midnight provides. So Midnight, what it does is it brings data protection to the blockchain, and I'm going to talk about this the entire time, so you're going to hear it many, 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 many times. And by the time you leave here, you should be able to repeat it for yourself, and you should be also to kind of describe, well, it works in this fashion. I also want to point out that the user is in control of their data. So when you're creating these transactions, they do not lose control of the information that's going into it. They keep it on their system. It doesn't leave their system. If you're a fan of our podcasts, we've had a couple that have come out. There's one coming out in the future that will actually show you the debugger and will show you that the information does not leave your machine. So I would encourage you to look up our shielded podcast and look for that next version. Yep.
I don't understand. If a doctor wants to see your medical records, how can it not leave your machine? He's got to read it.
So for a specific application, you can choose to transfer it, but it's by decision.
So what prevents entities from aggregating your data? So couldn't they just sell your data to an aggregator and then just start collecting different pieces about you and your...
If you're willing to give that data away,
Yeah.
in my mind, it's gone, right? And it can be aggregated. There are certain classes of data you got to be, the recipient has to be careful with how they handle it. But if it's not in that class, then yeah, I would assume that off to an aggregator it'll go. But we want to empower you to at least make the decision, right?
My own decision.
Yeah. Any other questions? No? Okay, keep them coming. And so what we believe this can do is it can drive regulatory-friendly applications, right? So if you have an application that you can challenge a user with a particular request that requires a private piece of information, for example, Mr. Beckmann, how old are you? Get your ID out and show it to whoever's asking. That information does not have to go off to the chain. It does not have to go off to the application. It can simply be retained by you, and you can generate a proof that allows you to substantiate to anybody else that I had a credential, that credential fulfilled whatever requirement I was challenged with, and you build a proof with that and include it in the transaction. That's what we can enable. So if you're building regulatory applications, in many contexts, you're holding the data. You're the data steward. That's a cost, right? It's a big expense to hold that and protect it and keep it safe. If you can transfer them into data processors, where the user's the holder of the data, then a whole different set of rules applies. It's actually easier for those dApps to be built and managed. So that's how we're going to help to unlock the Web3. And then we also believe that utility should not come at the expense of somebody's privacy or revealing somebody's data. And so we'll continue to hit that over and over throughout the day to show you how you can do this in your own applications today, literally today.
Somebody wants to know that you're of age to drink. The interaction is, you're saying a proof that you're 18 or whatever, 21?
Yeah, that app.
And not the actual age?
Correct.
Or
Yep.
birthday, okay.
Yep. There's enough technology that we can enable that. And if you think about it, right, if I go downstairs and if I looked like a younger man, they may ask me, sir, are you old enough to put that bet on the table? And I'd have to present my ID. What they're not doing is they're not phoning the state that issued me that ID to make sure that it's legitimate. They can trust it themselves, right? There's enough information in it that they can validate, yeah, this is a legitimate ID from this state or this country. So it's the same mental model.
How does it all start though? In the case of a KYC, what entity is determining that you're legitimate?
Yeah, so that,
past KYC?
yep, that comes down to a credential issuer question. In my case, in the real world, it's like I live in New York, it's the state of New York, or the government of the United States, but you have to find organizations that are willing to issue the credentials. And they do exist. There needs to be more of them, but they do exist.
Actually, I got a question from the stream.
Okay, shoot.
Our live stream, so I'm going to try to read it. I wonder if unshielded data could be held behind a permission wall. For example, when a doctor signs in to read your chart, he must e-sign an agreement not to share the information with third parties. So this is John Santi from the stream.
So thank you for the question. My answer here is that there are many ways of building your system, and there's many intelligent people here. You could certainly build applications that have different exchanges both within the blockchain environment and outside. So if you need to communicate some of the private data that you have to somebody else because there's a requirement for it, for example, my health data, I'd like to give that to my doctor so that they can know something about me. You would communicate that through a different channel because you want a much higher fidelity piece of information than what a chain could keep itself. But those types of applications are exactly the type that we want to enable.
John Santi just added a small comment there. This would prevent shared data from being sold. So
Because they signed something that said that they wouldn't, yeah.
Yep.
So keep the questions coming. All right, so let's talk about what Midnight is. So we're here at Rare Evo. Hopefully we're fans of Cardano and other technologies in that space. Midnight is going to be a partner chain of Cardano. What that means is if you operate a Cardano SPO today, you're going to be able to take an action on Cardano, basically putting your name on a roster. Once you put your name on that roster and you run the Midnight validator code, you will be a validator of Midnight and you'll be able to collect rewards in very much the same way as operating an SPO today. So by being a partner chain, this allows us to basically use the stake that SPOs have built up over the years, and those that want to participate, you'll be chosen for block rewards based off of that stake and everybody else that participates as well. So all the work that you've been doing over the last many, many years to just operate these SPOs and attract people to your pools, you'll be able to leverage that and operate a Midnight node in very much the same way. What else is Midnight? Midnight enables data protection. I've said this a few times, but we do that through zero knowledge proofs. That's where the data protection comes from. We allow you to write smart contracts that keep your data in control of the users. And the developer is they get to determine what the privacy mix is, right? So if there's information that needs to go and be public on chain, the developer produces this. The developer makes that choice, and they provide it through a DApp. So what this will allow is it'll allow differentiation between dApps, because you may find one DApp is a little more privacy preserving than the other, just depending on how the contracts were built. And if you can differentiate that, you may choose one over the other for one for your own benefit. Yep.
So as the control is then up to the developers, what mechanisms are there in place to protect users, to make sure that the users are understanding how it's developed and what's going on with their data? Because then I can imagine that possibly a developer might mislead users and do something with their data that they don't think.
Yep. So this is an area of active development for us. The academic space is taint analysis, so that you can tell if a piece of data has been tainted, is going to go and be public, or has been touched by a public piece of information. We plan to build that into our compiler so that through the compilation stage, you'll be able to identify it as a developer, as that this piece of information is tainted and can potentially leak. And then we hope to build tools off of that to inform the user, so that the contracts that you interact with will reveal the information that they're going to, in a way, leak through to the chain to try to inform you. Think of something like a permissions on your cell phone. Is it okay to use the camera? Is it okay to use your contacts? A similar interaction that can be embedded in your application. But those are spaces where contributions are very much required and needed, because how do we do the UX? How do we communicate this well, right? We're going to build and engineer the technology that can support it, but then you got to be able to reveal that to the user in a way that they can understand, and that'll be different depending on who they are, where they grew up. So that's where the community will very much help. Any other questions? No? All right. All right, so let's talk about private data in a transaction a little bit. So this will be a very light touch on how parts of ZK works. Basically a commitment nullifier mechanism. So similar picture to before. We have the user over on the left-hand side. The user has their private data. And on the right-hand side is supposed to represent Midnight, right? We have the unshielded, the shielded, and then the thing dangling down from the bottom, that's the Merkle tree of commitments. So what happens, how the user can actually stay in control of their private data, is the user has to retrieve the commitment that they're interested in from that tree, which this is just a read of information on the chain. That information is distributed all over the globe, so you can't triangulate anybody that's reading it, because I could read it locally off of my own node. That commitment information is taken by the user to generate a proof using a private piece of data called a nullifier that they have and they own. When you combine the commitment with the nullifier, that allows you to make another commitment. That's it. That's the mechanism. So they will submit a transaction with the proof of a new commitment, and then that commitment will get added to the tree, and the tree will now allow you to make the next step. It's way more complicated than that, but in a simple picture, that's basically the functionality. And so what you can do is you can have simple commitment nullifiers that are like spends of coins, right? I'm going to spend $5 and do that. However, you can very easily enhance that and put more information in here so that the commitments and nullifiers are more advanced. They have other things that are required to be able to produce the next commitment. For example, you have to show an ID, you have to use your fingerprint, you have to take some other step that requires that private information to be able to produce the next commitment. Any questions on that? So we rinse, wash, and repeat that over and over and over in every transaction that Midnight has that uses the privacy preserving capability that we provide. All right, so let's talk about the architecture a little bit. So if you're building or using a Midnight application, What parts of the system do you touch? I'm going to start on the left, and I'm going to move to the right. So the left-hand side, that's the developer. These are things that the developer wants to be able to interact with. So they have a contract, right? The first blue thing that they can run through the compact compiler, right? So your smart contract, you have a compiler, you can compile it, you can produce, and then you'll also produce the other infrastructure for the endpoints, so that you can call, from your web app into the chain, and you don't have to deal with all the mess of interacting with the chain. In addition to that, up at the top is your DApp code, right? So you're building an application to do something. We're not going to dictate what that is, obviously. Maybe you already have one. As long as you can take that application and deploy it in something that can interact with TypeScript and even bridge through other languages, then you can interact with our system. We'll expand to more languages as we go, but we're starting with TypeScript for now. The output of the compiler and your DApp code are combined together into a Midnight DApp. So that's the blue box in the center that's shown as running in the web browser. It's basically what you're going to do is you're going to import the Midnight JS library, and you're going to import the libraries that are the result of your compilation. And now you'll be able to call the endpoints that are built in your smart contract. So the methods or the circuits that are in your smart contract, we will provide you through compilation the TypeScript libraries that do that. And you simply import the library, and you write out the line, my contract.send. That's it, right? Very much like you've seen in many other languages, providing you the creature comforts where it's easy to read the software that's both in the TypeScript side and in the compact side, and build out your web app. That web app can be complemented with wallets. I'll show you an example where we use an older version of the Lace wallet. Other wallets that want to incorporate the Midnight technology, they are welcome to do it. We have a wallet guide out on the internet that describes how to do it, shows you where the libraries are, tells you what the steps are that you need to do to support it. But once you have the wallet extension in your web browser, now you have the DApp, you have the wallet, you have everything that a user needs to interact with your system. All right, now I'm going to diverge a little bit to tell you one more component that Midnight has. So you'll see down here at the bottom a proof server. So I keep saying that we make these proofs. Well, where do these proofs come from? The proofs come from the proof server. How that works is that the wallet, through a RESTful endpoint call, so just think of a HTTP call, talks to a proof server, provides the information that it needs to build the proof, it builds the proof, and then it communicates it back. This design has a few nice features to it. One is that proof server can run locally on your machine. So your information that's used to build that proof never leaves your machine, literally. Or if you're an enterprise, that proof server could sit in an IT environment where it can communicate over there and then come back to the user. You could also use third-party applications, but if you use third parties, then all of a sudden you're revealing that proof information to them, and they could take it and use it depending on what the terms of service is. So our current desired configuration is just run it locally on your machine. Works just fine. It'll build the proof, communicates the proof back to the wallet, which is also on your machine, and then submits that transaction to the chain. On the right-hand side, you can see the Midnight client services. So these are tools that you may run as if you want to be a DApp operator to help your customers. So there's an indexing tool that's shown up there on the top. We call it the pub sub indexer. Basically, it's indexing the chain. We have a UTXO chain, so you got to index it so that you can keep track of your balances and other things like that. And then it's pub sub because the indexer is going to watch all transactions go by, and the ones that you care about, it's going to publish and you're going to subscribe to them. So it lowers the amount of communication that has to go on. You can offboard this. There's no information that will compromise you. It'll be able to read your transactions, but it can't modify them. In addition to that, you can run a Midnight non-voting node. So if you're not an SPO, maybe you're a wallet provider, you're an infrastructure provider, you don't want to deal with the SPO side of things, you can run our validator node as a non-block producer. It'll sit there, it'll run, it'll validate transactions, it just won't produce new blocks. If you want to be a block producer, you have to go through the mechanism I talked before about being a partner chain. You got a question? No? You sure?
Yeah.
Okay, yeah.
Is it proof a binary result of a test? What is a proof?
So a proof is a zero-knowledge representation. So it is some very deep cryptography where you can present a piece of information and you can prove to somebody else that you know it without actually revealing that information itself.
Proving that you know it, is that just a yes or no?
Yeah, it turns into just a Boolean.
Okay.
Yep.
So in this diagram, that proof server is where your private data is?
Your private data is, in this case, it's in your web browser. But when you build the proof, you have to provide what's called witness, which we'll show a little bit later, which might be your credential, or it could be like, yes, you are an adult. That has to traverse the little black line and go to the proof server so the proof can be built. So there is some sensitive information that goes over this line. And you want to be conscious of that because whoever you're forwarding that along to, if they're less trustworthy, then you're kind of telling them things that you're trying to keep private. Yep.
This helps out the blockchain index. It's been done running it yourself, you're running it yourself, or you're, I know them, like Google has some, they are trying to build pub sub service as well.
So we today in our DevNet, we provide a pub sub service that you can use. You can just register to it and it'll work as any old pub sub would work. We also provide a packaged version of that software in a Docker container. So you can run your own. And if you wanted to place it in a cloud, you're welcome to. As we step towards becoming open source, me as the CTO, there's a bunch of things on here that I don't want to have to maintain in the long term. And I think that the community can really build some, very fast, very performant versions of some of these pieces of software. And so as we open source it, we're going to open source it in a way that drives towards specs so that you could replace it. If you don't like our pub sub server or it doesn't scale the way you want to, even though it does scale pretty well, you can replace it. And as long as you follow the spec, it'll work just fine. Same thing.
You're Ben.
Excuse me?
You're Ben, right?
I'm Ben, yes.
Okay, well, I video in contact with you, with Jack.
Yeah.
Oh, okay, yeah.
Yep, I remember.
Yeah.
Yes.
This is nice. That
Well, thank you. We have a very strong team working on this. I'm just the show pony, so. Any other questions before we move off this one? No? Okay. So the point of this one is that we do have a configuration. It does touch on capabilities that a developer would want, capabilities that a user would want, and capabilities of a service provider if you want to provide these. The nice part is you can deploy it in lots of different configurations. So if you have a different setup than what we have, it should be fine. You just have to figure out how that configuration can work for you. And by the way, it enables data protection apps. So it can fit in your environment and it can still provide you with this capability that we're talking about. All right, so then let's get to smart contracts. In Midnight, a compact is a smart contract. The word compact, think of like a history class where you're talking about compacts between countries. That's what it is. It's just a reuse of the term. Compacts consist of 4 things. They consist of some support libraries. Right now it's just the STD library, the standard library, but we imagine that will advance. There'll be more cryptography libraries, there'll be more helper libraries, utility libraries, so on and so forth. Maybe annotation libraries for proving things or knowing that it's functionally correct. Those kinds of libraries will come. The second item is that the compact ledger has a definition of basically the structure for your contract. We call it a ledger to overload the term, but you get to define your own. That's the public information that is shared across the chain. The third element there that's in between the black and the lower gray box is the user's private data. So I might refer to this as witness data. I might flip back and forth, but it's the private data. So there's some data that you retain, and in the contract you identify what that is, and you identify how to go get it, right? So like this method that is this witness method, that's where I'm going to go get that information from. And then the last part is basically where the sausage gets made. This is the circuit definitions. Circuit, method, kind of a swappable term. These are specifically zero-knowledge circuits. They're going to look like functions or methods to you, and those are just the last element of what's in a compact. Those compacts you can push through our compiler. The compiler's name is Compact C. It's available, again, publicly already. And what it does is it produces a compilation that targets the ZK circuits that we have today. So if you go through this process, you're going to run into what we call ZK-IR, ZK Intermediate Representation. It's a whole bunch of opcodes. The compiler targets those opcodes and produces a lower level program that executes those opcodes which run on top of our ZK circuits. Those opcodes will enhance over time. Just think of them as, you have a new processor in your laptop, you get new functions that make things run faster. We're going to do the same thing. But that's how that occurs. And then what those opcodes do is they run the circuits, and the circuits are just an arithmetization of a bunch of polynomials, which is the nitty-gritty of what ZK is. The nice part about this is you don't need to know anything about this side at all. You really don't even need to know anything from here to the right. All you need to know is how to write those compact contracts, and we'll take care of the rest of it for you.
The support library, what can developers submit to that library?
It's soon, yes. We are going to open source the whole enchilada, and you will be able to contribute to those libraries to extend them. I imagine that people will make their own, that they'll have extra capability.
Certified, are they checked for validity or
So,
safety?
We'll go through audits. However, the thing with ZK is ZK, because you go to a polynomial representation, it's a constraint system, so you can be under or over constrained. So we're going to go through a process as well where we take our circuits and by specification fuzz them so that we know that they're compliant at least as much as we can know.
Okay.
Yep. So we're going to use a lot of the tricks that we learned when building Cardano, where we formalize the ledger. We're going to formalize the ledger, but we also have to formalize our circuits. Any questions, comments? Anybody that wants to help with those formalizations? All right, so when you write a compact, you don't have to know what zero knowledge is. We provide you all of those tools. It's abstracted away. You simply have to write a piece of code that does the business logic that you want. And then we will produce the compilation of that, and we will produce the TypeScript endpoints that allow you to wire that directly into your application and call the transactions and execute whatever you like from your contract. All right, so now we're going to go and do some building. So I'm going to show you a couple videos, which I apologize for the videos, but this is simply so that we can get through things because downloading takes a little while. But then we are going to actually get into the code, show you the code, show you some of the nuances of the code, and then assuming the internet isn't acting up, we'll actually bring you into the application and show you it running. So hopefully Caesars has good conference internet. Okay, so community interest. As I mentioned, we have a Discord channel, and we have routine community meetings. I think every Friday, 1 o'clock Eastern is when those are, that people can participate in. And the nice thing is people want to show off what they're doing. They want to show off the capabilities they have. They don't have to give it away, but they want to talk about, I'm building an application for this particular use. What's up here on the board is just a small selection of a few of those types of applications that we're starting to see. So DeFi, right, of course, those are the first types that show up. Insurance. Interesting enough, we've started to see some healthcare ones, and we had some, I think, cleverly started with animals. So animal healthcare records aren't quite the same level as human. Identity. I've talked about identity a bunch, but being able to present a credential or being able to present a fact about yourself and take action on that in a contract is also something that's been arising out of the community, and we're seeing development in that direction. Gaming, we'll hear more about that tomorrow. But there are definitely applications where being able to prove that your score is correct, or being able to have an asset in a game that you can sell to somebody else or move to a different game. Those types of applications are arising as well. And then one even kind of more interesting version of that is you could have a game element where you don't actually know what it is, and it's kind of like a scratch off where if you want, you can reveal it, right? You can open the baseball cards and look and see who's inside, or you can keep it sealed and trade it later. And so it brings in a whole nother aspect to what these assets can be, because you can't, in some cases you may not even know what it is. And that may add to the excitement, which is an interesting little fact that shows up by having community participation. So there's a lot of these. Again, the community meetings, you start to get to see what the developments are in these directions. This is by no means an all-inclusive set. It's a large set, but there are others that are outside of this that are showing up, and obviously we want to support all comers. All right, so quick start. If you go to our dev docs, or you just shoot your camera at that link, it's going to bring you to our quick start guide. This is the intro to getting funds and transferring funds. And so I'm going to walk you through a video that shows that in a little higher speed than you may be able to get your fingers to go. But in general, you land, I apologize for the graininess, but you land at the quick start page. I'm going to just go through the steps. The quick start page links you off to a release page. Apologize for the white background. This will be delivered to you through your app stores. What's happening now is I'm downloading the version of Lace that we provide, which is a wallet. You can see it there. This wallet you can unpack. You'll see that it contains some contents, and what you're going to do is you're going to take that content and you're going to add that extension to your web browser, so to Chrome, and then you'll simply have a wallet, and very much any other web browser wallet type, through just adding that extension. So he's going to upload the pack, select it. There's the Midnight Lace wallet for DevNet, and then here in a moment I'm going to actually go and load the wallet. There it is. Looks just like Lace, right? It could look like any other wallet that anybody's used to. You go through the usual terms of service, give it a name, give it a password. This is the wallet I'm going to be using in a minute. Do your recovery phase. So this part is where you start to see where you can talk to the Midnight node, the indexer, and the proof server. So you can define these to be other places if you choose. Set up this step, which it skips, and then your wallet is all set up and configured. There's your address. You can take that address. It's going to bring you back to the quick start. It's going to tell you where the faucet is. So you take that address over to the faucet, click the big blue button, wait for the proof to get generated and then the blocks to get committed. You're going to get a transaction ID back, and then it's going to go and show the Lace wallet, and you get 5 of our test dust when you do this. You can come in and get more and more, but you really don't need that many because the cost of this is pretty low at the moment. And then the next step is if you want to submit a transaction, now you got to build a proof. So to do that, we're going to go and download the proof server. So this is a large file, so I wouldn't suggest doing that right now. But back in your room later today, if you like, you can download it. This will fast forward here in just a second. Yeah, you download it. It's a Docker container, as long as you're willing to run Docker. You run that command. It'll spin up the proof server, which is very quick, right? It's up and running right now. And then the last step of the quick start is to take some of those funds you just got from the faucet and send it to our buddy named Carl. It's just an address that we provide. Go and send a couple dust over to Carl. It'll take that request, it'll package it up, it'll give it to the proof server. The proof server will build the proof that's required to do the transfer, all hidden behind your beautiful user interface that's provided from the wallet that you're using. And you can see there's a pending transaction that will complete once the block is committed. Ta-da, you're up, you're running. You can both get and transfer funds, right? So that's the quick start. That's the very beginning that'll kind of get you moving. Any questions or comments? Yeah.
So just in that simple transaction, without anything being configured, you're sending, dust from A to B. What was hidden in that transaction? Like the amount that was sent, or what would be private in that?
So in that transaction, both the data and the metadata is hidden. So who you're sending to and from is hidden. The actual value is hidden, and there's no linkage even back to where you got it from. So it's a totally shielded transaction.
So I missed it in the beginning. Sorry, you might have covered it. So is this essentially like an L2 version of like Monero, but on Cardano?
So I would a couple caveats there. Thank you for the question, by the way. So it'll act as a L1. It's an entire chain in and of itself. It does link to Cardano through the partner chains mechanism that I talked about. And then the difference with something like a Monero is that you have the ability to reveal, but you also have the ability to keep things private. So you might think, well, Ben, that's just like Zcash. The subtlety is that now we have contracts, and the contract elements are what you can keep private. So we're providing you the tools where you can build compliant applications. And the way to do that is you have to be able to interact with some elements that you're not willing to share with everybody else.
Gotcha. Thank you.
There was, I thought, a question. Yep. Oh.
Online, which funnily enough didn't have to do with what you were showing. I had this question kind of like it's right into it. What are the relationships, if any, between Atala, Prism, Identis, and Midnight? There's a follow-up on that. But it was okay, well, thank you. We'll be building using the AP, Hyperledger SDK, etc. The shielding is important for our use case. So it's the same person that
Yep. So for those of you that are less familiar with what Atala Prism is an identity system. It's now referred to as Identis. It's a Hyperledger project. They're separate components. Midnight is a layer 1 that allows you to do anything you want, well, more or less anything you want in the blockchain context. Identist is an identity system so that you can have issuers produce verifiable credentials and give them to you. There are many identity systems, all of which provide you with these verifiable credentials. And if you can convert the verifiable credential into something that Midnight can consume, then you can integrate those directly and you can take action off of a transaction. So my comments earlier about if I go downstairs and try to put a bet, I could use a credential issued by Prism or Identis to prove that I'm old enough and allow the transaction to go through. So those are the types of innovations that we're looking for, is integrating these tools, these types of tools on top of us, because we think there's a lot of utility when you do that. Is there another question? Yeah?
So in that example, what is the proof of server doing in that? Is it checking there is enough dust?
So in that example, what the proof server is doing is it's literally, you have a commitment on chain that is the funds that were transferred initially, right? Like the 5 dust that you received. And then you have the ability to nullify that commitment and spend. And so what the proof server is doing is it's taking the commitment and it's taking the nullifier and building a proof that allows you to prove that I can spend these tokens. And when you spend them, the witness is that part of the witness is Carl, the address that you're sending it to. And so when you combine those all together, now you have the ability to say these UTXOs that are on chain are spendable by me and to whatever address I'm directing them to. So the proof server is just building the proof, but it's being provided that type of information.
Just does like basic validation. Just does like validation.
The validation is done on chain. So that when you do ZK, you do proof generation and then you do validation. The proof generation is what sits in your hands and is what the proof server is doing. And then when that goes to chain, it's validated. It's like, is this a legitimate proof or is it bogus? And if it is legitimate, then we'll put it in a block. Yep.
It seems that Nickname protects privacy by default as anything not programmed into the effects, function effects, of the ledger remains private by default. Is that correct?
If they wouldn't mind, can they wait a few slides to get into that? Because I will show you how that split happens. Because it's not really by default, right? There's usually public state that you're interacting with, and then there's private state that you keep yourself. If it's all private, the contracts become very one-sided, right? I can interact with myself only. There's nobody on the other side that I can coordinate with, and that may not be the most useful of application. I could play solitaire by myself. I've done that a lot. That's entertaining. But I would rather play poker, right, with other people, or battleship with other people.
So one more.
Yep.
Jojo, that you wrote us here. I'll make the second message because he's going to connect with us. But the first one, thank you. We have been building using the AP, now Hyperledger SDKs, etc. The shielding is repeat that one. Yeah, that's important for use case for us. Okay, yeah. So then he's going to follow up with us.
Okay, happy to have him. All right, so now I'm gonna move on to part 2 of the demo. All right, so building a DApp. So again, you are a QR code that will bring you to the tutorial for building. This is part 2 of our demonstration. So if you've walked through it and seen part 1 and part 2, this is part 2. So I'm gonna play the video here. So in part 2, we're actually gonna get into how the developer interaction works. Again, we're on the release page. Sorry you can't read this. It's not, the granularity is not all that great. But what it's doing is it's downloading the compact compiler, and it's showing you the methodology that you'll take that compiler and you unpack it, put those binaries in some place on your system that you're happy with storing the compiler and the other things that it comes along with. And then the compiler is actually functional. So he's going to go into that directory. He's going to find the compiler and he's going to execute a command to show you that it's live, right? So that the compact compiler itself is actually on your system. And in this case, he's got to do a change mod so that it actually is executable. So there's the compiler command, the version, right? 0.10.6 is the newest version that we have. From there, if you want to build an application that you can interact with, we support TypeScript, so you want to go use NVM, right, the Node version manager, so that you can get a specific version of Node, a newer one. Install that, and now you're able to interact because you have the compiler itself and you have the Node version that we support currently today. And then in everything that we provide, you have to do an install, right? There are various packages that we pull in from the internet. So you do an NVM install, you enable CorePack, you check your Yarn version to make sure it's up to date, and then you do a Yarn install and you get this type of output. And now you're getting closer and closer to actually having a functioning system, right? So I'm seeing some nods. You guys understand these crypto words that I'm using? So now he's going to go into the counter example. This is a very simple example where we increment a counter. That's not the one I'm going to focus on later. But a couple things you want to remember is you have a compact compiler. You should put it in your path if you want to be able to execute it from afar. And then there's also a compact home variable that you have to set. So if you're running into this and you're saying, oh, I can't find it, doesn't know where the home is, it's because those haven't been set. Once they are set, you just do an npx turbo build, and it will build the application itself, and then you're able to interact with it through the CLI. So we provide a CLI so that you can trigger commands, you can look into that CLI, you can see what the TypeScript code is that is produced and is used to do these commands, so you can, in a way, copy and paste your way to a very simple example. Right now, he's actually ran it, and it's syncing. And while it's syncing, he's going to go and get the compact plugin for VS Code, which will give you, some nice creature comforts for when you're doing your development environment. We'll see this in a moment, so don't squint too hard in a larger screen. But we're going to continue to extend that plugin to enable the language server protocol. So you'll be able to interact with this. It'll be able to tell you errors. It'll be able to point to the errors in the IDE, be able to give you what those errors are. You'll be able to jump to the definitions of the objects and the types, right? So this will get nicer and nicer over time. And then as we open source it, obviously all contributions in that space will be very welcome. And the nice thing about a language server protocol is it supports a significant number of IDEs already, hundreds already. So whichever IDE you use, it likely will already support that. As we move forward. Sorry. All right. And so then the last one, this is part 3, this is the DApp. We're going to actually get into the language here, and I'm going to show you running systems here in a moment. This one, you're actually going to start to create a DApp. So we provide it through the documentation in 2 ways. One way is the tutorial, which will walk you through construction of a contract where you're building it yourself, and it actually leaves a few blanks, right? It leaves a few things for the person to solve. But then we also provide a completed version where you can go and check your answers. So if you want to learn, you can go through this step by step, and it will challenge you, I think 4 or 5 times with go and complete this part of the code for how to get the secret, how to produce the secret, how to provide it as a witness, right? Kind of walk you through the steps of where the novelty of midnight is to challenge you a little bit. And as you're doing it, alongside, there's a complementary answer key. So if you get tired and you're just like, this isn't working for me, you can jump to the answer key and figure out how to produce the result. All right, so now we're going to get into what is a compact, and I'm going to test all of you guys' sight. Just kidding. I'm going to show you the bulletin board example that we have. The bulletin board is a very simple bulletin board. It's got 2 rules. First rule is you don't talk about Fight Club. No, kidding, sorry. First rule is anyone can post a message to a vacant bulletin board. So if there's nothing on it, anybody can come and post. All you need to do is know the address. The second rule is only the individual that posted it can take it down. That's it. Very, very simple set of functions. What's shown over here on the right is the actual compact code, which in the next few slides I will show you so you can actually see it. But you see the various components. Up at the top, there's not a box, but that's where the standard library lives. This is the public information definition, the ledger definition. This is the witness or the private data, and then this is your circuit definition, or AKA your methods that you use. And so let's look at what those look like. All right, so public ledger state. So when you define a contract, you have the ability to define a state that is going to be put on the ledger. That's what this is. So in this case, there are 4 public elements. One of them uses an enum that's up at the top, right? The state of the bulletin board, is it vacant or occupied? You'll notice that we have the identifier, and then we have some type information after that. So you see the word cell. What in the world is a cell? A cell is something that the ZK circuit can update. That's it. So it's just, it's an envelope in which the ZK circuit can modify the values inside of that envelope. So for example, when you're using a bulletin board and you post something to it, to be able to prove that you did that correctly, the ZK circuit has to update the value. So that's how cells are used. The next line, the message line, this is a little more complicated. Similar structure, you have the identifier, right? We call it a message. A message is a cell, so something that the ZK circuit can update that might have a value, so that's where the maybe comes in. And then that value is actually opaque to the circuit. The circuit doesn't care what message you're putting up. It just wants to know, do I have one or not? So that definition of what a message is allows this to be something that the circuit can update. So for example, if you have it, it can wipe it out. But the circuit doesn't actually need to know what the value of it is. And why do we do that? We do that because ZK is an expensive operation, the more math you make it do, the longer it's going to take. And so if we give you a few shortcuts or creature comforts, you can actually accelerate that. And so by making that message string opaque, just turns it into a hash, right? Something that's a fixed size. Circuit can work off of that very easily. If you don't do that, it'll cause the circuit to actually try to understand the string, which is more than what you need for this specific example. The third item, instance, uses a ledger provided type called a counter. This is what it says it is. You increment, decrement by 1, just kind of count up. We'll use this in a way as a salt, so that when you submit something, we can keep track of that you did this, and it was this particular instance of the posting a message to the bulletin board. And then the fourth item is the poster. So who is the individual that did the post? So again, it's a cell, so it's something that the circuit can update, and it's a bunch of bytes. That'll actually, we'll show you in a moment, that'll actually end up containing the crypto material that proves who you are without revealing the secret that gets us there. But that's what that is. And then the last part that's shown here is the constructor. So when you deploy the contract, something happens at that point in time. The constructor dictates what that is. So basically it's setting up a vacant board with an empty message and setting the instance at 1. Right, so this is we're gonna have our very first message. There's nothing in it, waiting for somebody to post to the bulletin board. So any questions on what the state of the ledger object looks like? Yeah?
What's the size of that counter? In 8 or how big is that counter?
Which one?
The instance, the type.
Oh, how big is counter? Oh, that's a good question. I honestly don't know the answer to that, but it'd probably be like 32 bits or some small, or it might even be smaller than that. It actually might even be smaller than that. But there is a limit to how big that counter can be. It's in the bytes, a few bytes range. And those are areas where it works today as people use the system and maybe have counters that go to higher numbers. That'll push us to make that be a larger field.
So the cell is the Boolean, right? Because it can array.
The cell is purely a type that is modifiable by the circuit.
Yeah, but how long is this? Is this 0101 or is this
It's like a pointer to something, right? So the cell is modifiable by the circuit, but that type doesn't tell you what's in it. Just simply knowing it's a cell, you don't know exactly what's in it. And so for example, this cell contains one of those two enum values, right? And this cell contains a string. But when you're looking at it from the cell level, you don't know that.
So is this the variable size? There's a storage with the variable size. Maybe a Boolean or could be a string.
Yes. Yep. Yeah, so I think in my mind, a pointer comes to mind, right? You have a fixed size thing that points somewhere else, and you can update that somewhere else through the use of the circuit. All right, I'm gonna keep going. So now that we know what the ledger state looks like, let's try to enforce some rules, right? So we have 2 rules. Rule number 1, which is written up there, is anyone can post a message to the vacant board. So in that box is the post method. I want to talk a little bit about a few of the keywords that you see up there. I'll let you read the logic just to prove to yourself that I can only post to a vacant board. But the very first word you see there is export. So when you're describing a circuit, if you export it, that means the compiler will build the integration so that TypeScript can interact with it. If you don't export it, it's private, it stays within, and the compiler won't produce those TypeScript elements. It's a circuit, and then it has the identifier, the parameters, and then the output is void, right? So that's how you define a method. The very first line inside that method is an assert. One thing to keep in mind here is the way that we use asserts is not the same way as some other languages use them. Sometimes they're compiled out, right? You use them as debugging or test tools, and when you optimize, and then compile, the asserts are removed. That is not what's happening here. These remain in the circuit. They are purely methods to enforce specific logic. So for example, that assert is saying that the state of the bulletin board is vacant. If that's false, then you get an error code, right? That says you're trying to post to something that's already occupied. And then the next 3 lines, the first one figures out who the poster is. I'm going to skip by that briefly for just a moment and come back to it in a second. The second one sets the message, and the third one sets the state of the bulletin board to be occupied. Right? So the logic makes sense. It's pretty simple. Let's go back to the poster part for a second. So this line right here. On the right-hand side of the equals, you'll see that the poster's value is assigned using 2 functions. One of them is a function called public key, which is shown down below. And the next one is called the local secret key, which reveals a little bit about where we're getting this key from. Ignore the local secret key for a moment. Well, I'll get to that on the next slide. Just think of that as an input that comes from somewhere else. The public-private key is produced using this method, which is just a hash of a hash. So you put in your secret key, you increment it, or you add a little salt to it, and you just rehash, and you're going to produce a set of bytes that are the public key. Since this is done in circuit, you can prove that whatever number came in, this math occurred to produce this public output, right? This public key. So the nice part about that is you could provide any secret key, and using the ZK methodology, you know that you constructed a public key in the appropriate way. But now you got to figure out where'd you get that secret key from? This is where midnight shines. The way that you get the secret key is shown there on the top line, is you identify what's called a witness. So this is a function that you simply, give the definition of what that function looks like. So what's its name, what's its input and output, what's its input parameters and output type. And that tells the compiler that there is a function that the system that this is executing on will provide to give you that information. And then it's up to the developer to figure out how to go and get it. So the nice part about that is it can be different from one device to another. So let's just use OSs for example. On one OS, the local secret key could be something that's captured inside of your browser and can be read in a very specific way. On another OS, maybe it requires you to go get a YubiKey and plug it in, right? But it's developer defined. So you can do that in lots of different ways. And the nice part is what the output of that is a byte string that contains your secret key provided by the local system, which is put through that function I showed you just a moment ago to produce a public key in a both secure and provable fashion, so that you know the public key is legitimate. And you know that the secret key never went anywhere because all you did was provide it to that one function. So just imagine expanding on that for anything else that you can fit inside of the local secret key, right? You could imagine lots of things. That could be a credential. That could be a hardware identifier that's in the TE on my machine. It could be all kinds of different things. Yeah?
You still have not written down one example of local secret key. How do you implement that function?
So that function, what the compiler will do is it'll build to a stub that is defined on that machine. So that machine provides however you want to manage and manipulate that secret key. The machine itself will provide that piece of code.
If I have a ledger wallet, can I implement this local secret key to get the and then to hash in my ledgers?
As long as your ledger wallet can talk with TypeScript, yes. Okay. Or you can bridge it through in one way or another. Yep. And so that's left to the developer to determine how they want to do that integration.
Do you have an example of how local secret key is implemented?
We do. So in this demo, and I could show you in a few minutes, it's just a simple function that just takes a number and passes it up. But you could definitely expand that into something more usable in the real world.
And here witness means, what's the meaning of witness here?
So witness is an input to the proof.
Okay.
So when we build these proofs, you have to provide inputs or witness data that then the proofs will say true or false, that this witness data was what was actually in existence when I built the proof.
And
So
that's supposed to be private.
the witness data it's the input to the proof, so it has to go to the proof server to be built into a proof. So you want to keep that proof server in your control or in a trusted party's control. But once the proof is built, then you're totally fine. That proof can go anywhere you like. And the way that the proof is validated is simply by presenting the same witness. And if you don't present the same witness, it won't validate it. It'll always be false.
So the private input with the public output, and then this witness is the private input.
This is the private input, yeah. Yep.
So specifically, a witness could be considered to be a getter for private data that's
Yeah.
concealed, on whatever screen you want.
Yep.
Okay.
Yep, that would be a much better way for me to explain it. Any other questions before I move on to rule number 2?
Someone just says hello from Bulgaria.
Oh, bye. Hello. All right, so rule number 2. Rule number 2 is only the person who posted the message may remove it. So in this rule, we have to be able to figure out who posted the message and are you the same identified person or this identified key. And then assuming we can do that, then we do the logic of actually removing the element. So in this case, you can see again on the top line, the very first thing that happens is you export the circuit definition. So the compiler will build the integrations that you need to be able to call that method. The method's name is takedown, and it returns a string that is whatever the string was before. The very first thing that happens is you assure that the billboard is occupied. There is something here, right? There's something to take down. And then the next thing you do is you assert that the poster is the same individual that provided the message in the first place. So you use the same computation, right? You produce your public key based off of getting that local information, and now you can do a simple equivalence check. Are those public keys the same? Yes or no? If they are, then you can proceed farther down, where you're simply going to record the message, set the state to vacant, increment the instance, wipe out the message, and then return the prior message back to the user. That's it. Any questions or comments about this? No? All right, so now we're gonna have a little more fun. Hopefully the internet is in my favor today. Let's see. So, actually, before I do that, so what we provide today allows you to come and use the bulletin board. This is an output of the terminal that shows you where I'm joining a contract that already exists, and I'm showing you the current state is occupied, and it says Viva Las Vegas, right? So that's one version of it. Another version of it is we actually provide you with a user experience where you can build this into a web app. All right, so rather than just kind of talking about it, I'm gonna pop up Visual Studio Code here. So what you'll see here is the same contract I showed you moments ago. Maybe bump it up a little bit. It has the same definition of ledger state. It has the witness, and it has the circuits that are down here below. The first thing I'm going to do, and maybe I went a little too far there, is I'm going to compile it. So this is taking the code and performing a compilation. And I just want to point this out to you, just so you kind of see it. Maybe you don't quite understand it, but I just want you to see what's going on. So when I do the compilation, it's going to produce two outputs. and we'll talk about why not 3 in a second. But each one of those outputs tells you what the complexity of the circuit that you're building is. The reason I'm bringing this up is as that complexity number goes up, it takes longer to build the proof, right? So these ones are reasonably low. Right now we're capping out at a complexity of 2 to the 20th in our constraint system, which is pretty large, but it may get bigger over time. And it actually shows you that both of them have very, pretty much the same complexity. So when you're building the proofs, it'll take about the same amount of time. There's a little fudge factor in there. And so then you might say, well, where's the third one, right? Because we had 3 circuits. We have the post circuit, the takedown circuit, and then we have this third one that's a public data circuit. The reason that the third one doesn't show up is the third one is a pure function. What that means is it doesn't touch private state, it doesn't touch witness data. It is pure to the context of what's being used here. So there is no inputs that are used inside of that function that come from somewhere else. It's pure. Everything that comes in, it executes and it produces the output. There's nothing else in the middle. And so the compiler figures that out. We are adding an extension to the compiler where you can state that these functions are pure so that you can avoid a few kind of programming errors that can show up. But since it knows it's pure, it basically expands the circuits above and just compiles it in together as an element of that, and it doesn't produce this output because it's already contained in those 2 numbers. So more enhancements that we're going to add to the language. Yep.
I'm not a developer, so this may be a dumb question. Is there a compiler error handler and a runtime error handler?
Well, so the compiler can produce errors, and it'll point to the line and tell you what's wrong.
Is that a Visual Studio thing?
The compiler will do it as we extend the language server. It'll start to get introduced into the actual code where it'll put a little squiggly line and point, here's where your problem is. And then as for runtime, when you build a transaction, there's a few different types of validation that happens. There's an initial validation, which is purely, is it formed correctly? Does it have the appropriate inputs? And then there's another validation on execution. At the execution stage, depending on how you write your contract, you could fail it. You could cause it to fail. Usually by developer choice. But there is a runtime that will capture that. Okay, so there's the same thing. Now I'm going to go into the bulletin board just momentarily. So scroll up here. All right, and hopefully this is still working. Let's just see. Yeah, still working. That's good. Okay, so I have a board. A bulletin board that is deployed to our DevNet. Its current state is vacant. It has no messages on it. I've obviously done this a few times. And the current poster is that. Okay, what does this mean? Well, what I really want to know is I want to know some information about what's being shown on both on the ledger that everybody can see, private data that I have, and then derived data, which is adding a little more information to make this clearer. So what I just showed you a minute ago, I gotta put my glasses on here, is that this is what is shared publicly. What you see in blue here is what's on the ledger. So anybody can read that. If I want to see what the derived data is, I'm gonna go look at number 5. And what this does is it tells me I am not the poster. Somebody else posted that information. So who posted that information? Well, I'm going to bring you over to the web app, which is this, and I'm just going to hit reload a second. So this is a web app that is running that contract and providing you with all of the TypeScript that you need to actually interact with it. I'm going to go and see if I can grab the contract address, which I believe is this one. Pop it in here. Hit OK. That will go and grab the contract. I grabbed the wrong one. Let me go grab the other one. So I have 2 contracts deployed. You can see that one of them is empty, and one of them is full, and you'll notice that there's a little interaction going on here. So this one was deployed by this, this device, and I can go and I can remove it, right? So it asks me for a transaction, I sign the transaction, it submits it to chain, you gotta wait for it to get to the chain, you gotta wait for a couple blocks to go by, but what will happen is it'll remove that particular dashboard, or excuse me, that bulletin board, and now if you wanna go and build a web app, you don't have to start from just our compact contracts, you don't have to start from just our command line interfaces, you can start from a fully developed web app and you can go from there. I just want to highlight that these exist, they're there, you can interact with them. I would encourage you to look at them because they're going to shorten your life cycle to getting to an answer or something that you can show off to your colleagues or your friends. But what we're trying to do is we're trying to build these in ways that are packaged enough so that you can make that step. All right, so back to the deck.
We were thinking in line to take this specific.
Excuse me?
We were thinking in line for taking this specific example and showing it. Someone that has already kind of like trying to run it, but like be running into some issues, and it's like, okay, it's good to see it.
Yep. So it's in, if you go look in the example applications under the BB board, the bulletin board, there's the contract, there's the bulletin board CLI, and there's the bulletin board UI, which is what that website that I showed you a minute ago was. All right, so enough with the code. Hopefully you guys got a taste that it's there. Hopefully I enticed you a little bit to come give it a try. Get a little feel for, what's it look like? Is this something I want to tackle or not? But where do we go? Like what's going on next? So let's talk about that a little bit. So we are in a way at the beginning of our roadmap because we're still early in our lifetime. So currently today, Midnight is running on DevNet. So you can come and you can use the tool, you can build everything that I showed you a moment ago, and shortly you're going to be able to be a block producer if you want. You'll be able to register and be a block producer. The features that are in that is we have shielded tokens, we have the compact smart contract language, and we have a Midnight specific version of Lace, the IOHK light wallet. So that's what's packaged in that today. We are quickly moving towards testnet. We will announce testnet when we have the ability to upgrade the chain without having to do a chain reset. So we still have a few things that we have to smooth out there. But what that will allow you to do is it'll allow you to do lossless upgrades of both the chain and your contracts, which by the way is a pretty sexy item, so that you can migrate from version 1 to version 2 to version 3 of your contracts over time, and you can actually inform the user that this is going on. We're going to add unshielded tokens so that you can mix and match depending on what your application is, right? Not everything is shielded nor is appropriate to be shielded. Sometimes you need to coordinate using public tokens as well. We will move off of the Midnight version of Lace, and it'll be embedded fully in Lace. So if you have Lace now, it'll just become a new feature that's updated to you, and we are actively working with other partner wallets to extend our reach so that we're not just stuck on one. And then in the near term, we're going to move to mainnet. So mainnet's coming, next year, early next year. That's when it will be live. In that, we're going to enable composable privacy. So if you have different smart contracts, be able to compose them together but still remain private. You're not going to dilute one with the other. We're going to have cross-chain bridges so that you can take the unshielded tokens and move them to Cardano or other places. And then we're going to have on-chain governance in similar way to what Cardano has, where you as a user of the system can vote on the actions and the updates that the system is going to enable. So that's kind of what's coming. Right now, we're actively pursuing individuals that work with wallets. We are going to go through a launch stage where we're going to get the coins out into the community. Wallets that want to participate in that need to support a few of the SIPs that are listed up there. So you need to be able to handle native assets, you need to be able to sign a message, and you need to be able to connect to a DApp. These are pretty common if you look at wallets. And that QR code points to is if you want to enable a wallet to become midnight ready, we provide you a guide that walks you through, here's the TypeScript code you need, here's the values that you have to provide, like, where's the proof server, where's the indexer, things like that, and how you can balance and submit a transaction. So that'll take you right to that. It's out, it's live. If you want to do those integrations, I'd give you a kiss, the more the better. And again, as with all things, if you find issues with it, let us know, and we'll get those out of there and make it a nice, smooth onboarding experience. Yes?
Can you review what role SPOs have in this process?
In the wallet process?
Or no, in publishing of, confused.
And like getting back to date for midnight.
Yeah.
Support it, yeah.
So the Midnight will be a partner chain of Cardano.
Okay.
If you're an existing SBO, you've spent time building up your stake pool and you have folks delegating to you and you've established that. And that takes a while. That can take years in some cases. To become a validator of Midnight, you simply have to go and execute a transaction on Cardano that puts your name on the roster, and then you have to run a Midnight validator node.
So they're not involved now.
Excuse me?
They're not being used right now.
We have a small group of friends and family that we're using to get the kinks out of the system, but that will shortly be opened up to anybody who wants to do it.
So if you go off chain to another platform, that works the same way? So you said you're eventually going to move on to other blockchains?
Oh, the tokens are going to be able to be moved. So if you have tokens that are resident on Midnight, we're working through the process with bridge parties to enable the movement and back, right? So you can go back and forth and put them in the place that you want. Yep, so if any of your wallet friends, feel free to point them our direction. All right, so other ways to contribute, hackathons. So we have one that's concluding while we're here. That's the Rare Evo one shown up there at the top. We have started our first virtual one, so a website that you can go to that you can do virtual hackathons. In Dubai in October, we're gonna do another one at the Cardano Summit. We're gonna do multiple virtuals. So I know it says the first virtual, but if you go to the events page, you'll see more and more get introduced as we get closer and closer to them. And then we're also working with an organization called Major League Hacking, who goes to many different locations, actually all over the world, and does in-person hackathons to extend our reach. So these provide our community with the opportunity to design, develop, compete, and then win various prizes that are going to go along with this. And I would encourage you, if you're interested, participate. Maybe you'll get paid for your time and be able to kind of build out the community with us. So last item I want to bring up is Midnight's open for all. It's there today. It's live today. I showed you the demos running today. You can connect with us in many different ways. Midnight.network is where you'll find information about the organization that's putting together the software. Docs.midnight.network is where all of our documentation is. You can join us on X if you want to follow us there, and I would certainly encourage you to join Discord, because that's how we're going to be able to connect and interact in a real-time fashion. Are there any questions or comments?
Now the phrase shielded kisses is trending on the chat. So that's thanks to you.
Well,
So now we have shielded kisses.
nice. That's it. Thank you very much. And for those of you that haven't seen us at the booth, feel free to come by the booth. And for those of you that were asking good questions, actually all of you that were asking questions, I have some midnight swag for you. Ugh. And I should have brought more so I could give some to everybody. But if you're not able to get one, just swing by the booth and we'll hook you up. There you go.
Thank you.
Yep. There you go, sir. I don't mean to skip anybody, but I am going to run out. You're welcome. You guys, yeah? Yep. Yeah? Oh, yeah, you're welcome. Thanks for coming. Looks like I'm one table short. Thank you. There you go. Yep. There you go. Oh, man, look at this. There you go.